Hello guys, I am Sudarshan Koirala and welcome back to Data Science Basics. This is the continuation video of LangChain series. I have already covered the video about introduction to LangChain, some quick start videos as well as some use cases. And now let's go through the components part. As you can see here, I already covered the introduction and the components part. I asked for my viewers if they want to have the video of different components separately or in one video, and they want it to be on one video. So this is going to be a long video where I will cover all the main components of LangChain. So after watching this video, you will know the main components of LangChain. As I said, the video will be quite long, but I will place the timestamps for each component, so feel free to jump into different components as you watch the video. Now without further ado, let's get it going. Okay, just the basic things before I get it going. The notebook will be provided to you and the link to the GitHub will be in the description box. This is the table of contents for this video. There will be a long things what I will be covering here, but I will provide each and every piece or the documentation for each and every component as well as the sub components while I go through the notebook. So feel free to click on the links and get the documentation for more information. Yeah, now let's start. First thing first, if you don't know what is LangChain, this is a framework for developing applications powered by language models. I recommend you to watch my previous videos where I have explained in depth about what is LangChain and the quick starter guide. Yeah, that is what in higher level, what is LangChain. First thing first, we need to set up the environment. If I just click this here, we need to first install the required libraries, that is openai and LangChain. I have already done this. Run this command and you need to get the openai API key. The link is provided here. If you just click this, it will take you to the API keys page. First you need to create the account and then create the API key and just paste the API key in this place here. Then you are good to go. Now let's go and see the first component. As I said, I will provide the link, so just feel free to click the link and it will take you to the official documentation of LangChain. But what is schema? In high level, it's just the basic data types and schemas. So nuts and bolts of working with large language models. You will know what it is after I go into through this specific part. So there are different subcomponents of schema. There is the text. When working with large language models, the text goes in and the text come out, right? It's the natural way to interact with the large language models. What is here inside the text? The text is, this is LangChain. So that is how the text is, right? We can just run this. That is it. That's nothing specific in this case. And now there is chat messages. What is chat messages? Similar to text, but with more of a message type. There are system chat messages, there are human chat messages, there are AI chat messages and all these things. We need to import those class from the LangChain. And the name is quite obvious here. LangChain.chat models, you need to import chat openai. And LangChain.schema, we have human message, system message and AI message. The name is quite self-explanatory here. So we just need to import that. And there is just an example here. We need to initialize the chat openai, right? Here I'm just initializing this chat openai and the openai API key is taken from what we just provided up here. So that is how it works. And or if you want to have more specific, you can just comma and then if you type here open, then it will suggest you to provide the openai API key, then you can provide it, but we already have on the previous cell, so we don't actually need to provide that, just not to have a confusion like where is the openai API key provided, right? So the next thing is we need to provide the human message for the chat, right? So here is translate this sentence from English to French. I love programming. If I just run this and then it will translate to French. Yeah, I don't know this, but if I say from English to Nepali, because I know what is Nepali language, and here it says Malay programming 1%, and that is the correct translation. Yeah, that is how it works. And you can even pass the multiple messages as it is shown here. And if I just run this command, yeah, it will show different things, but you can just provide any languages or any other task for this particular chat. And then you can even provide the batch messages. As I said, as it's shown here, there is two different things provided, and then it will go through the batch messages. If you just run this, then it will provide the answer. Yeah, that is how the chat message works, right? Now there is another subcomponent of schema called the examples. So it is actually self-explanatory here. Examples are input-output pairs that represent inputs to a function and then executed the output. So they can be used in both training and evaluation of the models. So there is not that specific examples I need to provide here, but if you want to go around, here is the thing, what is examples, or you can refer to the official documentation. Now there is documents. That is another subcomponent inside the schema. What is documents? That's the piece of unstructured data, right? Holds the page content and metadata. So I will show you what that means here, but as we progress through the notebook, you will get the idea, okay, what is page content and what is metadata, because when we start working with the documents, this comes as we go. But just for you to understand here, from LangChain.schema, we need to import the document. If I import this, then I can just pass the document, and here is the document class, and I just says page content, and I says, okay, the content of the data and the metadata, as I said. So you can just pass anything here. So document ID, document create time, or if you have other different metadata that you want to provide for this specific document, you can provide here. And if you just run this, it will just print that. So that is how the schemas work, because as I said, this is the nuts and bolts of the large language model or LangChain, so that all of these things will come when we start working with different components of LangChain. Let's go through the next component, and that is models. As the name actually suggests itself, different types of models that we use in the LangChain, right? So first, let's go through the language model. If you just click here, what is language model? It's the model which takes text as an input and returns text as an output. So here from LangChain.LLMs, I'm importing the openai, and here is just LLM equals to openai, and I'm passing the model GPT 3.5 Turbo and the temperature 0. And now I'm just asking what number comes after 2 into that large language model. So if I run this, it will say the answer, the number that comes after 2 is 3, right? By the way, you are not just restricted with one model, and here actually I'm providing openai and GPT 3.5 Turbo, but there are actually many models in the openai's endpoint. So if you just click this link, it takes you to the model endpoint compatibility. So here I was actually using the GPT 3.5 Turbo, and for the not for the chat models, right? I'm using for the normal completion kind of things. So it depends what kind of model you want to use in what kind of scenarios, so that you get the best answer out of it. Now let's go back to the notebook, and here I'm just saying now LLM Da Vinci, and OpenAI model name text Da Vinci, and I'm just initializing the model. And now I'm asking the same question, and what number comes after 2, and it says 3. But you get the idea that we can use different models from OpenAI, but some of the model goes with the chat completion kind of things, and some of them goes with the completions kind of things. So in LLM also there are actually OpenAI and there is chat OpenAI, two different kind of models, right? So you need to be careful when choosing the model based on your use case, so that you get the best result out of it. And now let's go with the chat models. So that is another subcomponent inside the models. A chat model takes a list of chat messages as an input and returns a chat message. That's simple difference here. So from the LangChain chat models, we take the chat OpenAI, and again there is human message, system message, AI message, and we can just initialize the chat OpenAI. And if I pass now, instead of just text, I just pass the content as a human message. So here I says translate this, malai programming man parcha. It works. It is similar to what I showed you before, but the different way of initializing the models, right? We could use multiple messages or batch messages as I showed you before. I'm not going through all that again, but you get the idea. Now there is text embedding models. What is embedding? A text embedding model takes a piece of text as an input and numerical representation of that text in the form of list or floats. Machine doesn't understand the strings or the text, right? It needs to be converted to numbers or vectors, right? So that is when the embeddings come into action. Here I said text converted to vector for machines to understand, right? In simple terms. From LangChain.embeddings, we can have OpenAI embeddings as well as the Huggingface embeddings. Just to show you that it's not necessary that we need to use the OpenAI embeddings, I will show you one example from Huggingface. Why I'm doing this is because OpenAI embeddings will cost you some money, but Huggingface is free. And if I go and see here Huggingface, if I just run this command here, embeddings Huggingface, it does not work by default because we haven't installed the packages. Just to show you that you need to install packages, I have set up the notebook in this way. The error message is quite self-explanatory. Again, it says that we need to install the sentence transformers. Yeah, let's install the sentence transformer because Huggingface embeddings use the sentence transformer behind the scenes. Now I am installing the sentence transformer, and once that is installed, and if we now again run the same command that I ran before, let's wait when that is installed. And by the way, if you are thinking what is this capture, this capture actually captures all the output when we install with pip so that it is not displayed on the screen when it is doing the installation. And now I can run the command, and now it should work because we have the sentence transformers. Let's wait. It is still loading, and now we will have the Huggingface. Yeah, as you see here, it is actually downloading those Huggingface embeddings, right? Yeah, it is downloaded, and now we can just pass the text. This is test document to check the embeddings. If I pass the test, and now embeddings dot embed query, right? And we need to pass the text. That's great. And if I just run this command here, yeah, Huggingface has 768 embeddings. So embeddings length is that, and the example, if you want to know what is embeddings, because as I said, it is a float, and here there are the different numbers representation, meaning that this is a test document to check the embeddings is being translated from text to the vectors, so that machines can understand that particular text. That is what embeddings is. This is the key part in working with the large language models, and you need to know what is embeddings. That's why I'm explaining you step by step here. And now let's go and see the example of OpenAI embeddings now. And now I can just download the OpenAI embeddings or initialize here because I already downloaded OpenAI on the first command, right? Now I just say text OpenAI embeddings, and I just pass the same text, this text for the OpenAI embeddings dot embed query. And then if I pass this text, it will go through. And if I run the same command, here you can see there is 1536 embedding length. And this is the example of the float or the vectors, whatever you call it, that holds that particular text. As you can see, based on the different embeddings, there are different embedding length, and of course the embedding vectors will be also based on that particular embeddings. Yeah, that is how it works. It's not that hard, but you need to know how LangChain components work. And this is all about the models part. Next, let's go through the prompts component. In simple term, what is prompt? It is the input to the model, right? Whatever goes into the model, that is called the prompt. Before we just pass in the form of text, but now that text is provided to the prompt, and the prompt is passed to the large language model. That is just the different way of passing things into the model. So let's go through the prompt template. So here there is nothing. From LangChain.LLMs, I'm importing the OpenAI, And the next one is I am initializing the model, LLM equals to openai, and there is the prompt, what comes after 2, right? And now I'm passing that value to the large language model and it says 3. So that is what we did before, but here in a more organized way as a prompt. Now let's go and see the next subcomponent of prompts, that is prompt template, which is a better way of prompting. That's just the normal saying. Contains a text string similar to the F string of Python. If you are familiar with Python, I hope you are, because you are watching this video which is all about Python and what it is. And for just the sake of simplicity, here is the example how F strings works. You name the variable and you pass that variable in the F strings in the curly brackets. Now it prints hello Sudarshan because it takes the name as a variable and we just pass here. Similar to that, in prompt template here from LangChain.LLMs, we import openai and the prompt template, and we import that, and this is how it works. You just create a template and you just say something here. I want you to act as a naming consultant for new companies. What is the good name for a company that makes? And then instead of hard coding the things, we just pass the product, right? And there is the prompt, and let me expand this. There is the prompt template, and here we just pass input variable as the product, templates as the template, and then we set prompt.format product, and we can pass anything here. I'm passing here colorful socks. I just take this example from the official documentation. If I run this, it is what it's just showing here, right? What text and colorful socks. That's what I'm just doing. I'm not doing anything here. Here I just want to show you that if we pass like this, and if you want to have further more examples, you can just modify one line of code instead of going and modifying the template. That's the simplest way to do. Yeah, that's all for this part. And now let's go to the example selectors. What is example selectors? So I'll just show you the example here. From LangChain.prompts, there is the prompt template, few short prompt template, and length based example selector. And here I'm just saying that, okay, examples, and I'm passing the examples here. So input is happy, output is sad. Input is tall, output is short, meaning that I'm providing just the 5 examples. So that is how the few short works. I'm just passing 5 examples. Let me create this example. And now what I'm doing here, let me explain you step by step. Example prompt, I'm just creating the prompt template. Input variable is input and output, right? Here is the input, here is the output, right? And the template is input, and we are passing that input, and the output is, we are just passing the output. And here we are creating the example selector. So we have length based example selector. That's just the class I am using here. So here is examples is examples. Example prompt is example prompt that we just created. Max length is 25. I'm just providing this. By the way, I'm just taking the example from the official documentation, so you can just refer to the documentation also. And now here is the dynamic prompt. We are using the few short prompt template, and here all the things are provided what I'm just creating here. And if I just run this cell, it says the length based selector is not defined because I think I didn't run this cell. Now it should work. Let me run this again. Yeah, it works. And now here example with small input, so it selects all the examples, right? I'm setting my adjective as the big, and I'm passing here dynamic prompt.format, and I'm just passing my adjective. If I run this, it will give us, here you see that it provides all the examples here, give the antonyms of each input. Here is the example: happy, sad, tall is short, energetic, lethargic, sunny, gloomy, windy, calm, and the big. And what is the output? Now we can say here LLM, I'm taking the language model, and dynamic prompt.format adjectives. Here I'm just passing just to show you how it looks, and now I'm passing that into the large language model. And if I just run this, it should give me small because the antonym for big is small. Yeah, that is how it works. That is how easily you can make your different examples based on this example prompt. Now let's go with the output parser. As name suggests also, it is the parser, or it formats the output of a model, because the output of the model can be in different things, right? You need to have in a particular format. So here are examples like get format instructions, and there is parser, and there is also the example called parse with prompt, just to show you how it works. Here I'm just importing from LangChain.output parsers. What is this? Comma separated list output parsers, and another is prompt template openai. That is the normal things that we just import, right? I import here and I just initialize the comma separated list output parser, and here is just the example. I'm creating the prompt. So if I just run this, and now I'm taking the model from openai, I can just pass the LLM here, but it's fine. So I said here input is prompt dot format ice cream flavors. I just want to have the subject here, right? Input variables as the ice cream flavors, and now it is passing output equals to model output. And what is the output? Just to show you, here it is vanilla, chocolate, strawberry, but it is not formatted properly. What I can do now is output parser dot parse, and I can pass the output. That is what it does. It formats in a list. That's the name suggested. It formats the output that we get from the large language model. That is what it is doing. Next, let's go and see the indexes. What is indexes? It's the way to structure documents so that the large language models can best interact with them. So I will just show you step by step. There is the document loaders. What is document loaders? I have already created a video just before this where I have explained how you can chat with different documents. Please refer to that. But I will show you the example here. There is the link or the documentation. As you can see from the link, there are so many different document loaders. You can just go through and get more informations. But here I'm just going to show you the simple example. Let's go and see here. From LangChain, the document loaders, I can just import the Huggingface dataset loader. I'm going to show you the example how you can load the dataset from Huggingface, right? So if I run this, it will run the Huggingface dataset loader, and I just want to have the dataset name IMDb, that is the movie dataset, and page content column is text, and loader is Huggingface dataset loader, and I just want to have the dataset name and the dataset's content, right? If I just run this, we have that all. Now I can just say data is equals to data or to loader.load. Okay, we still get some error. What is this? As you can see here, when we want to work with the Huggingface, when we want to work with the models, we need to have the sentence transformer. Now we need to work with the dataset. In order to work with the dataset, we need to install the datasets library from Huggingface. So for that, I'm just installing the datasets here. Install datasets. It is going to install all the datasets provided by the Huggingface. So that's the reason I'm saying you Huggingface is an ecosystem of, let's say, machine learning, because it has all the things that it needed. Now if I run the same command, it will work. Data equals to loader.load. Right? And as I said, when we are working with Huggingface, it needs to download the dataset now. So it is taking some time to download. As you can see here, it is downloading. And once it is downloaded, I'm just saying here, okay, print 2 of those. So here it will print me the dataset. Let's wait when it is downloading. It's now generating test split. Okay, unsupervised splits. Let's let it do its part, because we just want to see how it works, right? And then you can use it in your specific use cases, whatever you want to do. Okay, all is downloaded. Now we should have some output. Let's see. Okay, yeah, that's how it works. And now I can show you what I said in the beginning, right? In the documents, there is page content and the metadata, right? So if you see here, we have the document, we have the page content, meaning that the content, and I just ask here to provide 2, right? That means that there should be 2 of those. If you just look here carefully, here we have one document, yeah, and then there is the next document here. So here is the document and there is the page content, and if you just go somewhere here, there is the metadata. That is how it holds in the document. I hope now it is clear for you. Now let's go and see the next subcomponent, that is text splitter. As the name suggests, we are splitting the text, right? Splitting of a document into the smaller documents. Why it is necessary? Let's just open this first. I am providing the documentation, all the links. So LLMs has a limit of what they can accept, right? You cannot dump all the things into the large language model. So it has some length of input. Just to show you what I mean, link to the OpenAI website. Here is GPT 3.5 model. It can accept, so the particular model that I am using is GPT 3.5 Turbo, and it can accept 4096 tokens. So we cannot provide more tokens, right? For that, we need to split the documents into smaller chunks. That is what the text splitter is made for. I'll show you the example, then you will be clear. Simplicity, I'm just providing you the example of LangChain.text splitter, markdown text splitter. If I just run this shell, now I can just provide some text in the markdown format. Here is the LangChain, some examples. I can just run this. So the markdown text variable has all the markdown things. And now I can say here, markdown splitter, markdown text splitter. I just want to have the chunk size of 100, chunk overlap 0, so that I don't want to have the overlap between the two chunks. If I just run this shell, now that is already done. If I just provide the docs, so what is docs now? I split it here, right? I just pass the text splitter, right? Here I said markdown splitter, the variable that I created here, and dot create documents, and then I need to pass the text that I created just here. When I pass this, it is creating the documents now. If I just see how many documents are there, there is 3 documents. So as you can see here, this particular text is now converted into 3 different chunks. If I just want to see the docs itself, as you can see here, there is 1 document, there is 2 document, there is 3 document, because we divided that into 3 different chunks. As I said you before, there is page content and metadata, page content and metadata. I hope now it is quite clear. Now let's go and see the next subcomponent, that is the retriever. As the name suggests, it makes easy to combine the documents with the large language models. So for simplicity, I'm going to show you the Vectorstore retriever. What is Vectorstore? It is a way where you can save your vectors, meaning that after you do the embeddings, the text is converted to vectors and we need to store them somewhere, hence the name Vectorstore. And there are actually many vector stores. There is a Pinecone and other different kinds of online vector storage, and for locally there are Chroma, and then we can even go with 5 CPU and so on. I will show you one example with 5 CPU. For that, I need to have some document first, right? What I'm doing here is I'm just downloading the technical report of GPT for all paper. If I run this shell, it is going to download. If it is downloaded or not, in Google Colab, if you click this files icon here, it will be shown here. So it is downloaded. If you want to have the link, you can just say file copy. It will just copy the path, right? But now I need to have the 5 CPU, tick token and PyPDF, because if I go and run these cells, it will show me the error that I need to have. Just to show you example, okay. It says, as you can see here, it says pip install PyPDF, because I'm using the PyPDF loader to load that particular PDF. I need to have the PyPDF loader. And just to show you, if I run this following shell, it will show me some error. Let's see. It should show me some error related to the 5 CPU, because I don't have the 5 CPU. So it says it says to install me the tick token, because that is what is needed for the OpenAI embeddings, right? So, and there should be somewhere about the 5 CPU. I think that comes after this step, so it is not shown here, just to show you what it is behind the scenes, right? So if I just install this, pip install PyPDF, tick token and 5 CPU, now there shouldn't be any errors. So that is how you go step by step, instead of installing everything at once and you don't know what is going in which part of the document. Now if I run this particular shell, there shouldn't be any error. because now I have PyPDF already being installed, and now that particular PDF that I just downloaded here is being loaded by PyPDF loader. And now I am actually importing different things here. Here is character text splitter, the recursive character text splitter. You can use any of this. I'm using character text splitter right now. And here is the files, that is the Vectorstore, OpenAI embeddings. We need to have that. Here I'm just saying, okay, loader.load. There is the text splitter, there is the text, there is the embeddings, and there is the Vectorstore. There are many things happening here, but I think now you already get the idea, because first it needs to split the document, and then it needs to do the embedding, and the embedding is then going to the Vectorstore. There is 3 different pieces joining here together. If I just run this now, let's see if it, okay, it runs, right? And by the way, the DB, now it is stored in the DB. For now it is stored in DB. By the way, if you want to know how Pinecone works, just the previous video where I explained how you can chat with different documents, I have explained how you can create the index in Pinecone, how you can get the API keys and all these things from the Pinecone, and how you can load the vectors from the Pinecone. Feel free to watch that. It will be in the description of this video, or it will be maybe appearing on the right corner of your screen right now. Now if I just say DB, what is DB? It is just the LangChain Vectorstore and the files, right? Now that is all. What is the retriever? That's the main part is here now. So here is the DB, that is the Vectorstore, and we just pass as retriever, and then we have the source quarks. I just want to have the one. If I just run this cell, now that is retrieved from there, and now I can say by default the Vectorstore retriever uses the similarity search, right? If I just pass this particular text here, docs is retriever dot get relevant documents. By the way, just to show you a high level thing here, when we are passing how is the training done sentence here, what it is doing behind the scene is converting that into the vectors, and then that vector is going to be compared with the vectors that is in the Vectorstore, and it will find the similar chunks of that documents and provide us the documents. Here if I just run how many length, it will show us 1, because I just said here pass me 1. If I just pass this 2, and then if I just run this again, and let me run this again, it should show me 2, because I want 2 of those chunks from that Vectorstore which is related to this particular text, how is the training done. I hope it is clear now for you. Now the Vectorstore, I explained all the things for you just here, but it's the database to store the vectors, right? I'm just showing here because that is the subcomponent of indexes, right? Just for the simplicity of explaining all the things, I'm showing you here so that you don't get confused. And here I'm said you have length of text documents. You can just now query it through the documents or the text. And then next, embedding list, embedding.embed documents. If I just run this, there is nothing going here, but I'm just showing you how it can be done. And this is what I have already done earlier, but just to show you, as I said, there is 3 different embeddings, because we have 3 different documents and we are embedding that, meaning that we have 3 different embeddings. How the embeddings looks like, it's shown here. So that is how the indexes work. In the beginning you might be thinking, okay, there is too much to take, but practice makes you perfect. Always go through this document or through the documentation of the LangChain. Practice, practice and practice. You will know what is going behind the scenes. Okay, next we will be going through the memory. So what is memory? The concept of storing and retrieving data in the process of the conversation, right? So when you go through the ChatGPT or something else, when you ask something, it remembers the previous one, right? If it just remembers the previous one, that is called short-term memory. And if you have a long conversation and if you ask, okay, what did I ask you in the beginning? It will give you the answer, right? So because it remembers many things there, so that is the long-term memory. That is how you can understand in a high level. There is chat message history. There is the documentation link. go through that. Here what I am doing for you is I'm just from LangChain.memory importing the chat message history, and here I am just initializing the chat message history, and I am just add user message hi, add AI message what's up. So that is how we can create the chat message history, right? So if I just print the history.message, you can see that first I asked okay hi, and the AI message says what's up. That's what I provided, right? It's not what the AI provided, but I will show you here that now I will just add one more add user message to just reply to that AI message. Fine, what about you? If I just run this shell, as you can see here, it shows hi, what's up, and fine. So there is the history being maintained, right? Now if I pass these three different chats to the chat, meaning that to the language model, let's see what it responds to us. So it will respond based on this conversation something to us. So here it says as an AI model, I don't have any feelings and all these things. So you get the idea. We just provide the two different things in the beginning, we just add other things, and then we pass into the model and it's providing us the reply. Now if I just add here okay history.add AI message AI, and you can see that there is human message, AI message, human message, AI message, and all these things going one after the another. That is how the memory things work. I hope it is clear for you. Okay, next let's go through the chains. That is where the LangChain comes into hand, right? So what is chains? So chain means, as the name suggests, we chain different things, right? So as I go through, you will get the understanding. So there is one sub component that is called chain. A chain is just an end-to-end wrapper around the multiple individual components. I don't need to go through this, you get it. Now the main thing is the LLMChain in LangChain, which is mostly being used. I will show you how it looks like. Here I am importing the prompt template, OpenAI. This is just the normal things we just went before. There is the prompt template, and from the chains I'm importing now the LLMChain chain, right? I'm now passing the prompt and the LLM. So there is the prompt, there is the language model together in the form of chain, and if I run this now, it will give the same answer. Happy huge socks. Okay, I'm going a little bit fast here because this is what I already showed you in the previous steps, right? Now if I just want to have the chat, and there is chat OpenAI prompt template, tell me some joke, and LLMChain is LLMChain. There is the chat, there is the prompt, and if I just run this again, it will show us some jokes. Okay, corny. Why did the tomato turn red? Because it saw the salad dressing. Yeah, that's fine. Okay, so many of you asked in my previous video that if it is possible to use the Huggingface Hub models in the LangChain, right? If you don't want to use OpenAI, is there any other models that we can use? Yeah, it's possible. So for that, what you need to do is you need to have installed the Huggingface Hub. So pip install Huggingface Hub. I have already done this. And then you need to have the Huggingface API token. So for that, you need to go to the Huggingface Hub website, and actually you can take any models here. I'm taking the Flan T5 axial model, and you need to get the API key, right? For the API key, after you logged in into Huggingface Hub, go to this link here, and there is this settings icon, and here there is this SS tokens, and here you can create the new token. Just copy this token from here, go back to the notebook and paste here. I have already done this, so I'm not going to do it again. So once you are done with these 2-3 steps, you are ready to go. So now how it works is from LangChain, you need to import the Huggingface Hub, right? And then repo ID, you need to take the model that we just took. This is the model that we took from Google. You can take any models, but you need to be careful that not all the models actually work, because only the text to text or text generation kind of things only work right now in LangChain. You can refer to the documentation for what kind of models it will support when you are watching this video, because right now just the text generation kind of models are supported. Now it's the same. How we can do, we can create a Huggingface Hub model, and we pass the repo ID here. Temperature is 0, max length 64. You can play around with this. So now I can run this. Now let's go through one example. Same thing what we did before. From LangChain, we import the prompt template and we import the chain. right? LLMChain. There is the template, question is question, answer is let's think step by step, and prompt is prompt template, and you just pass the question. And there is the chain, LLMChain, same as before. There is the question now: who won the FIFA World Cup in the year 1994? So if I ask this question, and now I can actually LLMChain.run and pass that particular question. So if I run this, now it says that the FIFA World Cup is a football tournament that is played every 4 years. The year 1994 was the 44th FIFA World Cup. The final answer is Brazil. So Brazil won the FIFA World Cup 1994. This is how you can use the models from Huggingface Hub. So you are not restricted in using the OpenAI only, but as I said before, you need to be extra careful what kind of models are being supported by LangChain when you are watching this video. Now there is another thing called index related chains. I'm not going through in details here because there are so many things inside this. So there is stuffing, there is map reduce, there is refine, there is map re-rank, and all these things. This is actually the simplest one is the stuffing. We stuff all the things together. And there is the map reduce, which breaks down the document into smaller chunks. There is the refine, which further filters the results from the map reduce. And there is the map re-rank, which reorders the results based on the relevance. There is the documentation. Please go through that for more detailed information. And now let's go and see the summarization part. Here I'm just importing like open all the things, like I don't need to go again and again this. And here is the large language model, and I'm just importing the text splitter at character text splitter. I just run this, and now I'm just showing you the text because I am already running this just to show you what it is. The text is what I take it from the GPT-4 for all papers, right? So I'm just going to use the same text. Now here I'm just saying that langchain.chains.summarize, import the load summarize chain. I'm going to summarize here, right? This is how the summarization actually works, and this is kind of a use case. I have already created a video about summarization, please refer to that. But here the chain is load summarize chain, and chain type is map reduce. As I said we can use different kind of index related chains, right? This summarization chain is an example which I'm showing you in the index related chains. So I'm using the map reduce, right? If I just now go to this particular cell, and if I run this now, as you can see here, there is a chain being created here. Where it is? Entering a new map reduce document chain. Here it says something prompt, after prompting write a concise summary. Okay, now it went through all the different things, and here it actually prepared a summary for us. And what is the summary here? This is the summary being printed. Just to explain this in brief for you, we have the whole GPT for all paper. We split that into chunks and we had it ready as a text, right? And now I'm passing that text, and I asked the LangChain to provide the summary of that for me, and now it is providing the summary. Now this is really useful because if you have long papers, if you want to just have the summary of those, you can quickly pass that into this particular chain, and then you can have the summary. That is simple. I hope you will use this quite often, and I see many people are using this because who want to read all many pages of paper if you can just summarize in just the sentence that it is just shown here in this format. That's great, right? Finally, now we are going through the last component called agents. Some applications will require not just the predetermined chain of calls to the large language models, but potentially an unknown chain that depends on the user's input. I have already created a video about AutoGPT using LangChain. You can refer to that. Just to show you, I have provided all the links here. Refer to those particular documentation in LangChain. They have explained quite well there. Just to show you, there is a tools. That is, tools are the ways that an agent can use to interact with the outside world. There is toolkit, that is the groups of tools. And then there is the agent itself. There are different types of agents for a specific task. And then there is the agent executor that takes an agent and tools and use the agent to decide which tools to call and in which order. That is how the agent works, right? I hope you already know what is AutoGPT. As I said before also, I have also created the video, and in internet there are lots of video out there. You can just go through that and see what the agents can do. But I will show you one example here. So the example one, there is two examples. Example one will be the Python REPL tool. Why is it needed? Let's go through that. So here from the agents.agent toolkits, import that particular method, and we have the Python REPL class also here. And from the LangChain.python we import Python REPL, and LLMs OpenAI we just import the OpenAI. We run this now. Now we create the agent executor, right? We create the Python agent, and there is the LLM, there is the tool, and the verbose is true because I want to see what it is going through when it is executing this particular agent, right? So if I run this, and now here is the thing, agent.executor.run, what is the 10th Fibonacci number? So I just want to run this, right? I haven't provided anything here. So now as you can see here, it is entering a new agent executor chain, and let's wait when it is going through. Okay, so it went by itself, right? I didn't provide any other information which actions to take one after the another, right? So here it says by itself I need to calculate the 10th Fibonacci number. Action is Python REPL. Action input is, there is a function here. If you can see here, there is a function, and it creates a function, and now it prints that particular function, and the observation is 55, and thoughts is I now know the final answer. Final answer is 55, and the final answer is 55. As you can see here how powerful it is. Let's go and see the self ask with search, another example, because I just want to show you also the Google search kind of things. Here, as we will be using the SORP API wrapper. What is SORP API? That is the API that we can use to search the internet, right? Here we need to have the Google search results also. But before showing this, I will just show you here that if I run this particular shell, which is provided by LangChain, as you can see here, it says that it needs the SORP API key. That's the reason I'm already showing you that, okay, you need to have these things, right? First, we need to install the Google search results Python package, and you need to go to this sorpapi.com website, create an account. After you create the account, you need to just go to this link. It will take you to the particular link here. I'm just showing you the link here because I'm going to again regenerate the API key just to make you sure, because I get many comments that, okay, you have shown your API key, please revoke it, all these things. I will revoke it because I'm showing this for purpose just to know you that you need to take from where, right? So now I have this, and now this is the API key, right? Now if I provide the API key, and what I'm doing here is before running, I'm just taking the SORP wrapper, API wrapper, and here initialize the agent and the tool and the agent type, and other things are the basic. I just want to provide something here. I just run that. Now it's working, and now I just say that self ask with source, initialize the agent tools, LLM agent types is the type.self ask with search, verbose true, and what I want to ask, what is the hometown of the reigning men's French Open? If I run this for you, what it is going to do, as I said before, it's entering the chain and it is going to do things by itself. What I'm saying here, what is the hometown of the French Open's reigning men's, right? What it is doing here, it says yes, follow-up question, who is this, right? Who owned the French Open champion? So it says no good result found, and again it went here, follow-up, who owned the men's French Open in 2020. So 3-time defending champion Rafael Nadal defeated Novak Djokovic, this and this, and now it says intermediate answer, Monaco, Spain. So the final answer is Monaco. It says that what is the hometown, it is providing here it is Monaco, Spain. I don't know if it is correct, but you get the idea that it went through different things. It asks or sorts by itself, and it provides the answer for us. Just to make sure if it is correct or not, we can just type Rafael Nadal town. Let me see what the Google says. Okay, it's Manak or Spain. So that is correct. By the way, it just did the Google sort, right? I didn't need to go through that. Anyway, and now the last thing here is on my, I think, chat CSV video or some videos, one of my viewers says that is it possible to show the intermediate answers or not? Yes, it is possible. How you can do that? For that, the same thing I am showing you here, but you need to pass the return intermediate steps equals to true. That is when you need to pass this to true in order to print the intermediate steps. And one thing here, what we did, self ask with source dot run, right? But when we have the return intermediate steps, we cannot provide the run method here. We just need to have the response, because that is where we are actually capturing all the things. So if I just run the same command here, it is doing the same thing now, but here we are just running the chain and we are not storing it somewhere, right? Here we are storing that into the response variable, right? The answer will be the same here, it completes, right? And if you can, how you retrieve that information, you need to have the JSON, just import JSON, and we need to just dump the JSON.dumps, and the response is what we have here, and the intermediate steps, and indent equals to 2 because I want to show it properly. So if I run this command, it will show you the intermediate answer. I hope now it answers your question. Yeah, that's all for this video. I think it's already almost 50 minutes or so. I hope you find it interesting. Go through all the different parts. Let me know in the comment section how far you went, or did you face any difficulties running this. It was long video. I hope you learned something. If you learned something, please like the video, subscribe the channel if you don't have already, because I'm going to create many educational videos in the future. Thank you for watching and see you in the next video.